Here at the Georgia Robotics and Intelligent Systems Lab, or the GRITS Lab for short, we study control theory and robotics. And control theory is the hammer. It's the tool we use to solve complicated problems. And the nail is robotics. And in particular, we're interested in lots and lots of robots, so swarm robotics. Swarm robotics is the study of how should you design systems that let multiple large collections of robots solve complex problems that they couldn't solve by themselves.
Robots need not be super intelligent all the time. So instead of making one robot really, really smart, you have lots of dumb robots that together figure out what to do.
When you scale up, there's no way you can have a single central brain telling everyone what to do. So instead, you have to have simple local rules. And local means I'm a robot. I can only look around and see my neighbors because I don't know what all the other robots are doing. I only see the robots around me. And based on these simple interaction rules, you need global properties like can you cover the area? Can you build the particular type of formation you're interested in a provably correct way? So the idea is to go from simple rules to beautiful global behaviors.
Nature tends to do this very effectively all the time. In fact, we see when we have a flock of geese flying information, we have schools of fish, pulling these spirals, and they're using very limited information to do all this.
To me, and to everyone doing multi-agent robotics, nature is absolutely the #1 source of inspiration. So one way you can think about this is to think of us as math translators. So we're taking biological movements and then turning them into tight pieces of mathematics that we can code down and then deploy on the actual robots.
There's no rules for how to do something brand new. And so that takes a lot of persistence and it takes a lot of creativity.
With all this complex math and algorithms and stuff, you actually translate all that into robots playing piano. Music is just a really creative way of showing or demonstrating so many other tasks that the robots can be doing.
A disaster area, or a cleanup after a nuclear accident. You can send out robots to do the job that people shouldn't be doing. So people talk about the dull, dirty, and dangerous jobs that robots can do.
The most gorgeous thing about this lab is that we are very creative and we are given that absolute leeway to just go crazy with whatever we want to do.
The overriding motivation is to upend the way we do things and to change the world in order to make the way we do everything better.
Georgia Tech and the GRITS Lab are most certainly and definitely shaping the future of what robotics in general and multi-agent robotics in particular is going to look like.